Hello everybody, my name is Loïc Lejeune and welcome by this very first episode of this new series and the first episode of this channel in general. So, like I said, my name is Loïc Lejeune and what I'll be teaching you is how to build one of these right behind me. So this is a redstone computer. It's as simple as it gets. This one, if you get any more simpler, it isn't really called a computer anymore. So this is simple, the simplest computer you can make. I am currently working on another one that is a lot bigger and has a lot more functions. But I'll begin to teach you with the basics. So this is a lot more complicated. Also, quick note, I'm currently debugging this thing, just began, and that's a really big part of making a redstone computer. So I really want you to know that because it's not a fun part either, and it takes a long time. I was not looking forward to it, but you have to do it, otherwise it doesn't work. But with a small computer like this one, the debugging should stay bearable, at least. Bearable. So in this first episode, I want to quickly go over what I will teach you all, guys, and all the different components of this computer. So let's get right to it. The first one is, as you see, first of all, I have already divided this into sections. So the green one is the entire computer, and every color itself is a different component. So we start with the orange one. This one is the bus. For this one, I will actually go to my complicated one because it's exactly the same, but that one is really messy. So this one is a way better example. What this does is it just connects all the different parts of the computer so you can transfer data on it. It's by far the easiest to make. There's only one hiccup actually, and it has to do with these things, but I'll get to that when the video of the bus comes along. Next one is the second least complicated, and that's this one. That's the register. In this component you can store data. This one in particular can store 4 times 4 bits. So if you don't know what a bit is, I'll cover that next week. But basically it's just one zero or 1. So it's just one data that can either be 0 or 1. So in 4 different places you can store a 4-bit long string number actually. So that's one upon index. Immediately, this is a 4-bit computer, meaning it can process 4 bits of data. This bus is also 4 bits. Now what we'll see in this register is the different addresses. The addresses where you can store different data are stacked on top of each other, and each module to store 1 bit of data is the same. Like, I didn't mean to do that, is this thing. So from beginning here to end over here. So it's 1 byte, and it's a really useful component I designed myself. I'm sure you can make this a lot smaller, but it's just one I designed. So this can store 1 bit of data, and with this line you can control when it needs to store one, otherwise if you just power it, it will just always pick that. It will just always store what it gets. Now with this line you can control one, and I noticed that this is broken. It is 100% broken. I need to replace these for upstream. I'm sorry for this. So what I'll quickly give you guys, for this series you don't need any understanding about computer science or how a computer works. The only thing you need to know as basic information is redstone, how redstone works. I won't be covering that. If you want to, I can make a series about that. I'm not an expert in it. I'm not an expert in making redstone machines either. But I think that's actually a positive point, because what I found when I needed to do research how to make these things is, if you look up videos with people that make crazy machines, like they're absolutely wild, you can't, as a rookie, you can't really understand anything of it. But me, that I mean, I'm not an expert, like I said. I think you can understand what I'm saying, because for me, I use the easy terms as well. I make everything easy. I use my own terms. I can teach you my own terms. I think it will make more sense. But anyway, those were the registers. Now we get to the ALU, and this part is for uh, actually the arithmetic, so counting, subtraction, but also for logic. Logic gates, I mean just logic things, in, just to combine things in logic gates. Won't That will be not the next video, but the video after that. I'll be covering logic gates, so if you don't understand it, don't worry. But this one can only actually do addition, so you can load two numbers in it. This is where the addition actually happens, and then you can output back on the bus. So now the next one is this one, the input. So here you can control, here you can send the data on these things, and you can write it to the bus. So you can write a custom number to the bus, and this can be very useful, in fact. Now to the biddies, the most complicated, that's the control unit. And here the control unit is actually divided into two parts. First of all is ROM or RAM. For me it's ROM because that's a lot easier. Read-only memory speaks for itself, I guess. You can only read from it, not write with. That's not the case for RAM, where you can read and write to it. Now, and this one is control unit itself. As far as control units go, this is pretty simple, and that's what really set it apart from that one, where the control unit is a whole of a lot more complicated. Making the LEU bigger and giving it more functions is not that complicated, but this is by far where you have to do most debugging. This one can do a lot. So how it basically works, the basics, is there are different lines, and on each line you can give it instructions, so it will jump from line to line with the clock you make. And on each line it will give the computer an instruction that it needs to perform. So, and it has a few other functions as well. I mean, this one only has the reset function, but I'll get to that when it comes along. So now, for example, it's set on the 8th line, and that's this one, and this is the function halt. I know, and what this does, it just basically stops the clock from running. So it doesn't recycle, because if this wouldn't happen, it would go back to 1 and then go back to 2. So this is the way to stop it. Now, this is the control menu. This is a lot of function, and it doesn't really have that one does, but this one doesn't really have an easy IO, this input or slash output, because it's all really manual. You need to really understand the machine to use it. You also need to manually write the programs, things like that. So that's basically it. That's basically the whole computer. And for ending, I want to give you a little. I want to show you what it can do. So I loaded already up with a program. Here I have loaded up the number 3. Here I have loaded up number 4, this one. And what it will do, it will add these two numbers and store it here. So that would be 7, and that is 7 is 0 1 1 1. So now it's set to 0 0 0 0. This, by the end of the program, that should be converted to 0 1 1 1. So I set it all up and now it should be working. So let's enable the program and unhold the computer. So now it's on line 1. We already loaded the first number into the ALU. That's the second one. Now here we already see the answer. Now it just needs to be transferred back to registers. Okay, it's already there. Now we just need to be yes, that's already set, and we should be on the last line. Yes, that's correct. So now you see the number 7 is stored in here, and the bus is clear, everything is nice. This is not really nice, but if you write over it, that's not really a problem, and you can assign program to make sure that that's empty. Just didn't do that this time. So I hope that I look forward to more of this content and how you actually need to make the machine instead of just a showcase. So if you enjoyed it, please consider subscribing. It would really make my day. And thank you for watching. See you in the next one. Bye.